Okay, this is the next titration. So we have made up 0.1 molar solution of a sodium hydroxide, and we have standardized it against a standard hydrochloric acid solution. So this hydrochloric acid solution we've standardized previously in our previous experiment with our previous titration. And just on the previous page here, we should have that molarity of that HCl that we're going to use in this experiment. So when we titer these two against each other, they're going to produce a sample of sodium chloride, which is table salt. This is the chemical equation here: HCl, NaOH, salt, and water. So if we flick to where we're going to fill in the little pieces of information here. The volume of NaOH, this is our base, so it's going to go into the conical flask, which we were going to pipette when we were measuring it, which is going to be 25 centimeters cubed. The molarity of the HCl, again, this figure is from your previous titration, so I have 0.11 moles per litre in my one. The volume of HCl needed, this is going to be different depending on what your titration was like. But in this one, you see that they've overshot. This is their rough titer. Then we have two titrations that are roughly the same, and they're in agreement of 0.1. So what I'm going to do for the average titer is take the two closest titrations, add them together, and divide it by 2, and I'll get this number. So this is my average titer that I'm going to use in the calculation to find out the molarity of the sodium hydroxide. Okay, so methyl orange then was the indicator because it's a strong acid and a strong base. We move down, this is the formula that we always use for our titration experiments. It contains acids this side and bases this side. So the volume for the acid, that's your average titer, so whatever you got, you can put it in here. My one is 24.85 centimeters cubed. The molarity of the acid we worked out in the previous titration experiment, so this number again is probably going to be different for you. The number for the acid, you can find that from your chemical formula. It's an imaginary 1 up here and an imaginary 1 for the base as well. So Na is going to be 1 and Nb is going to be 1. The volume of the base was 25 centimeters cubed because that's what we pipetted up. Switch over for the calculation section. Okay, now it's focused again. So calculations then, we're just going to fill in our formula. From the previous page where we've already labelled out what Ma is, what Va is, what Na is. Okay, so you can see that we're only missing one variable, so we can go ahead with using this formula. If we put all this in the calculator for me now, I'm going to get this number. So you are probably definitely going to get a different number for this side, okay? Because you'll have a different molarity for your acid and you'll have a different titer. So if you have a different number here, that's fine. But now whatever you get here, you're going to take this 25 and divide it into it. So the molarity of the base that I'm working out is 0.109. Or if I round that to 2 decimal places, 0.11 moles per litre. Okay, so you can write that in here. You can write it as molar either. So express the concentration moles per litre, 0.11 moles per litre. And then in grams per litre, if you want, we can come back up here and do a little section to convert to grams per litre. We're going to use this formula. number of moles equals mass over the relative molecular mass. And remember, this 0.11 molar is for the NaOH. So the relative molecular mass of sodium hydroxide is 23 for the sodium, plus 16 for the oxygen, plus 1, which is 40. The number of moles we have is 0.11. We don't know the mass, but we know the relative molecular mass is 40. So 0.11 times 40 equals the mass. So the mass that was used to make up a litre of 0.11 solution is 4.37 grams per litre. Okay, so we can just put that in here. So if you wanted to make up this molarity of solution, 0.11, you'd weigh at 4.37 grams on a weighing scale and dilute it up to a litre. Okay, that's that one done.